Hi, in this video we're going to write a series in what's known as sigma notation. So the question says, write each of the following series in the form of sigma from 1 to n of a of k. So you've got 3 plus 7 plus 11 up to 23. We've got 2 minus 4 plus 8 minus 16 to minus 256. And we've got C1 plus 2/3 plus 3 over 5 plus 10 over 19, and finally we've got 1 plus 3 plus 9 plus 81. Now, if you've done arithmetic sequences and geometric sequences before this, you might find it useful when having to write these as in sigma notation. So we'll take the first one, 3 plus 7 plus 11 up to 23. First thing we do, we recognise this is an arithmetic series because we're adding it together. And where any term of a arithmetic sequence series will be un is equal to a plus n minus 1 times d. So we identify that a is equal to 3, and we see that 7 minus 3 gives me 4, 11 minus 7 gives me 4, so d will be equal to 4. So writing in the information into this formula, we get un will be equal to 3 plus 3n minus 1 times 4. And then if we simplify that, we could write it like that, but it would be better if we just simplify it. That becomes 3 plus 4n minus 4, which gives me 4n minus 1. 3 take away 4 gives me minus 1. Now we want to find what this term is. We could write them all out and just work it out manually, but algebraically we need to just put 4n minus 1 equal to 23. It means that 4n is equal to 24. Solving this, we get that n is equal to 6. So our series 3 plus 7 plus 11 up to 23 will be sigma for the sum of from 1 to, now n is 6, so here we now put a 6, and we now rewrite this, but instead of putting n, we're now going to put k. So we get 4k minus 1. So that's the answer. Right, the next one, 2 minus 4 plus 8 minus 16 up to minus 256. This is a geometric series, and any term of a geometric series is un is equal to ar to the n minus 1. So we've got the first term, a is 2. Now, this is an alternating series as well. It goes from positive to negative. In order to do that, we need to multiply by a common ratio of minus 2. 2 times minus 2 gives me 4. Minus 2 times 4 gives me plus 8, etc. So writing this down, we've got that un is 2 times minus 2 to the n minus 1. Now we could leave it like this, but we could write 2 times minus 2 to the n, and then we have a minus 2 to the minus 1. Now minus 2 to the minus 1 is 1 over minus a half, so that will now make this down, simplify down to minus brackets minus 2 to the n. Now we need to know what term number this is. So we've got minus 2 to minus 2 to the n is equal to minus 256. We could write them all out and just work it out manually. Dividing through by minus 1, we're going to get minus 2 to the n is 256. So if we now make the base the same, that means that n would have to be equal to 8. Now, so writing down our series, that will be, so 2 minus 4 plus 8 minus 16 up to minus 256 will become sigma from 1 to 8 of brackets minus 2 to the k. Now, however, it might be better to write, and it could be written as sigma 1 to 8. This is quite a useful technique. I'm putting in here minus 1 to the k plus 1, or it could be k minus 1. And that will ensure that the sign changes of just plus 2 to the k. And therefore we don't have that minus sign in the bracket. So this is quite a useful technique when writing series in sigma notation, because this will ensure when k is 1, we get that minus 1, 2, and this will be squared. But when k is 2, we want minus 4, so that will ensure that... so 2 plus 3, and minus 1 to the cubed is negative, so it's minus 1 to the 2, which is 4, so we'll get minus 4. So this ensures that the series will alternate. quite a useful technique. Right, the third one is a fraction. Now, what a good idea sometimes to separate the numerator and the denominator. We can see straight away that n is equal to 10. And if we write the first term as a fraction as well, 1 over 1, the numerator is also an arithmetic series. We probably don't need to actually do this bit. We got that un is a plus n minus 1 times d. So a is 1 and d is 1. First term, second term. We're just looking at the numerator here only. So using this, we've got the first term plus n minus 1 times the common difference. That gives 1 plus n minus 1, which just gives n. For the denominator, it's also an arithmetic sequence with first term 1 and common difference 2. So un will be 1 plus n minus 1 times 2. And we've got 1 plus 2n minus 2. 1 minus 2 is minus 1, so this becomes 2n minus 1. So the sigma notation of the fraction will be n over 2n minus 1. So we've got 1 plus 2/3 plus 3/5 up until 10/19 will be 1 to the term number, which is 10, of k. We now write those in terms of k over 2k minus 1. So separating the numerator and the denominator when we've got fractions is quite useful when we've got series. Final one, 1 plus 3 plus 9 up until 81. This is also a geometric series with first term. So un is a r to the n minus 1. So the first term is 1 and the common ratio is 3. So un will be 1 times 3 to the n minus 1, which is just 3 to the n minus 1. We need to know what term number this is. Again, we could just write them out, but it's useful to know how to do it algebraically. 3 to the n minus 1 is equal to 81, and therefore 3 to the n minus 1 is equal to 3 to the 4. So that means that n minus 1 is equal to 4, and therefore n is 5. So therefore, 1 plus 3 plus 9 up until 81 in sigma notation is from 1 to n, so 1 to 5, of 3 to the k minus 1. Obviously, we write it in terms of k. Okay, so this has been a video to show you how to write different series into sigma notation. I hope you've understood, and I thank you very much for watching.